So, okay, let's first of all, a small revision of what you guys already know, and then we will take a look at some new pieces of information. You already probably know what redox reactions are, right? Redox reactions are reactions in which oxidation and reduction occurs simultaneously. Meaning that oxidation and reduction reaction will occur at the same time. Both of them will happen at the same time. What is oxidation? We all know quite well what is oxidation. Oxidation is the loss of electrons or the gain of oxygen or the loss of hydrogen. All of these are considered to be oxidation. Ideally speaking, oxidation is loss of electrons. But if you can see that an element is gaining oxygen or losing hydrogen, so you can say that that element is being oxidized as well. You can safely say that as well. On the other hand, when we talk about reduction, so what is reduction? Again, we probably know the definition quite well. Reduction is gain of electrons or gain of hydrogen or the loss of oxygen. So a redox reaction is a reaction in which both of these are going to go ahead and they're going to occur simultaneously, right? Now, when we are going to go ahead and talk about it, so we can figure out if a redox reaction is taking place simply by taking a look at your half equations, right? For example, let's take a look at a few half equations. Let's take a very simple chemical equation. Okay, we have sodium, solid. That solid sodium is reacting with Cl2, which is gas, to give us NaCl. For example, all right. Now, in this particular situation, we can go ahead and make two half equations. The first half equation, to do that, we first need to take a look at charges. Now, sodium is going to have a charge of 0, 5, because it's an element. Elements always have charges of 0. Similarly, chlorine is an element, so it will have a charge of 0. In sodium chloride, sodium has a charge of +1 and chlorine has a charge of -1. Now, what are the rules for oxidation states? We will discuss it. I will go over with you guys all the rules for figuring out the oxidation charges. All right, I will go over all the rules with you guys in a bit. So what are we going to do? We have sodium that has no charge in it. That sodium is going from 0 to +1. So it's becoming more positive. Whenever any element is becoming more positive, that's because it is losing electrons. Remember, when we lose electrons, we become positive. That means our sodium is losing electrons to become sodium +1. Now, we don't like to write electrons with a negative sign, right? I don't like to write just as a standard, just as a universal standard. We don't like to write down electrons with a negative sign, which means I should move my electron to the other side, just so that I can write it down properly in terms of the universal standard. So my equation is going to become that my sodium is equal to sodium +1 and +1 electron. So over here, even though the equation shows +1 electron, but we can clearly see that our element, this element, sodium element, is losing an electron and it's becoming +1. So what is happening? over here, we are seeing reduction. Sorry, I said reduction, oxidation. Loss of electron is oxidation. And if we go ahead, we take a look at the second one, that's chlorine. So our chlorine over here is becoming Cl minus 1, meaning that it is gaining an electron and it's becoming Cl minus 1. Now, when we are going to go ahead and we're going to talk about it, we have to remember that we have got two molecules of atoms of chlorine, right? The formula is Cl2, which means we will get two chloride ions. And the same thing you can see in the balancing of the equation I did. I wrote down two chloride ions. Since I need two chloride ions, so 2 multiplied by 1 is 1. Sorry, 2 multiplied by 1 is 2, right? 2 ones are 2. That means I need 2 electrons. All right? That's my equation. I have balanced my equation. After balancing my equation, I can see that quite clearly my element is gaining electrons. Gain of electron is reduction. So this is what is oxidation and this is what is reduction. So this is quite a simple concept. You guys have studied this in your IGCSE, and it's something that should be quite perfectly clear with you guys. Now, when we are talking about our oxidation and we're talking about reduction, so we can see quite clearly who is being oxidized and who is being reduced, right? And when we are going to go ahead and we are going to talk about it, so this was this is what oxidation and reduction is. Now, we also have to go over oxidizing agent and reducing agent, right? We are talking about oxidation and reduction, so let's talk about oxidizing agent and reducing agent, right? So first of all, let's go ahead and before we can talk about that, let's first discuss some rules. Rule number 1 that we have to go over, the first thing that we're going to go over is how to balance half equations. So far, up till your IGCSE level, you were dealing with really easy equations, right? When it came to balancing of half equations, you guys were dealing with really easy equations. Now you guys are going to see how you can balance equations when you're dealing with slightly complicated stuff. So what is going to happen is this. Let me put a question in front of you guys for practice, and then let's go ahead and study how to solve that question. How will we balance our half equation? So question is this. Construct the balanced ionic equation for the reaction between nickel and iron 3 ions from the half equations. So the question will be like this. This time in your 8th level, they will provide you with the half equation. The half equation will be given to you guys. You guys will somehow have to use the half equation to figure out the overall equation. This first question I'm doing with you guys is actually a really simple question, and you guys are going to go ahead and see how is it such a simple question. So when we talk about it, we have our nickel and iron. We have to figure out what the equation is going to be. So we have to figure out the overall total equation, the overall equation. Now, we don't know, you have never studied the reaction of nickel and iron. You don't know how to construct it. You're like, I have never studied the reaction of nickel and iron. I don't know what the reaction is going to be. Two half equations have been provided to you guys. Okay. The first equation is the equation for nickel. You have your nickel, and this is nickel 2 plus 2E. The second equation provided to you guys is this. Fe 3 plus E gives us Fe 2 plus. That's all they have given. They have given you these two half equations, and they're saying use these half equations and figure out the overall balanced equation. Now you're like, okay, I have never studied the reaction between nickel and iron. How am I supposed to know what's going to happen? Now, what you have to do over here is that, first of all, let's see if we can figure out who is being oxidized and who is being reduced. As you can see over here, my iron 3 plus is gaining electrons to become iron 2 plus, right? So what are we going to go ahead and say? Since iron is gaining electron, so iron is being reduced. Now, nickel is losing electrons. It's not gaining electrons, even though the electrons have a plus sign. Why? Because if I move these electrons to the side of the nickel, because the reaction is between nickel and iron, not nickel ions. It's not between nickel 2 plus and iron 3 plus. It's between nickel and ion. So we need to take a look at nickel, the solid, the element. Is that losing electrons or gaining electrons? So the nickel metal, the nickel element is actually losing electrons. Right? Because if I move this to the other side of the equation, it will become minus 2E. So my nickel element is losing electrons. My reaction is with nickel, not with nickel 2 plus. So my nickel element is losing electrons. Hence, this is oxidation. Once you figure this out, how are you going to actually go ahead and solve the question? To solve the question, what you need to do is that you need to write down the two equations on top of each other like this. So first write down nickel, then make your arrow, nickel 2 plus 2E, like this. Okay? Then write down your next equation. Your next equation is going to be, now match the arrows. Okay? My arrows will be on top of each other. My arrows will be on top of each other. On left side of the arrow, I have Fe3 plus electron. On the right side of the arrow, I have Fe2 plus. I'm going to add the two equations to get my final answer. But before I can do that, I have to make sure that the number of electrons on the left-hand side are equal to number of electrons on the right-hand side. In equation number 1, I have 2 electrons. In equation number 2, I have just 1 electron. I need to figure out a way to balance the number of electrons. The number of electrons on the left side have to be equal to number of electrons on the right hand side. How can I do that? How can I make sure that the number of electrons on the left side are equal to number of electrons on the right side? This you guys will have to figure out yourself depending upon what kind of equation is given to you guys in the question. Okay, depending upon what kind of equation is given to you guys in the question, you guys will have to figure it out yourself. But in this question, it's quite simple. We can take the lower equation and we can multiply it by 2. If I multiply the whole equation by 2, my problem is solved. Now I have 2 electrons on the right hand side and 2 electrons on the left hand side. After you have balanced the number of electrons, the rest of the process is quite easy. Simply add everything up. So let's start with adding everything up on the left hand side. I have Fe3 plus. How many Fe3 plus? 2. Why 2? Because I had to multiply the whole equation by 2 to balance out the number of electrons. Secondly, we have nickel. So we write down plus nickel. What about the electrons? Now, this is why we are spending so much time on balancing the electrons. I have 2 electrons on the left hand side and 2 electrons on the right hand side. I can cancel them out because they're on opposite sides of the equation. If they were both on the same side, both were on the right hand side, both were on the left hand side, then we would have to add them up. But if in your equation, anything is on the opposite side, not just the electrons, there is some ion, there is some element, it's on opposite side. One is on the left hand side, one is on the right hand side. So you will subtract them. Remember that. If they're on the same side of the arrow, add them up. If they are on the opposite sides of the arrow, subtract. Okay? So over here we can subtract our electrons. So next we have our arrow. Then we will add everything on the right hand side. On the right hand side, I have nickel 2 plus and iron 2 plus. So there we go. All done. This is the final and complete balanced equation for the reaction between nickel and iron 3 plus ion. Right? So this is how you can take two half equations, balance out the number of electrons, and use them to figure out what the overall equation is going to be. This equation that you and I just made, this equation is known as the overall ionic equation. That's what it's called. This is known as the overall ionic equation. Got it? We understand so far. This is clear. We understand how we're making our ionic equations. Anybody has any questions? Any confusions? No. Aruj, everything is clear. We understand so far. All right. Now, that was an easy question that I gave you guys, right? Let's go slightly tricky. Let's go a little bit tricky. Okay? When we are going to go ahead and talk about it, let me put an equation in front of you. Construct the balance ionic equation for the reaction of iodide ion with magnate 6 ions in the presence of hydrogen ions using the half equations. Now what? Now what do we do? Now what do you and I do? How do we figure this out? What are we going to do? Right? Now, again, they will provide you with the ionic equations. So these two ionic equations, they have gone ahead and they have provided to you. So they have gone ahead and written down for you equation number 1. Equation number 1, they have told you is you have your iodide ions, and this is the equation for it. Over here, what is happening to the iodide ions? Are they being oxidized or are they being reduced? The question is about iodide ions, not iodine, about iodide ions, which means I need to take a look over here. What is happening to this? Is the iodide ion, this is what I want to find out. Is this losing electrons or gaining electrons? If you take a look, you can clearly see that it is losing electrons. The iodine is gaining electrons. The iodide ion is losing electrons. So it's being oxidized. Then when we go ahead and take a look, equation number 2 provided to you guys in the question is, we have our magnate ions, MnO4 minus. The 6 written in the question is not the charge of the magnate ion. It's the charge of this magnese. Magnese is a transition element. It has got variation charges, right? Variable charges. So the charge of magnese is +6. This is a compound, it's a complex ion. Okay, these kind of ions are known as complex ions. Complex ions are ions made up of different elements. So over here we have manganese as well as oxygen. Okay, plus 8 hydrogen plus 5 electrons. And this is giving us Mn2 plus 4H2O. Now, in this particular situation, if you guys are going to go ahead and you're going to take a look, you're going to end up realizing that your manganese is being reduced. How can you guys tell in this particular question that manganese is being reduced? You guys can tell by the fact that over here, your manganese, I told you guys that the manganese has +6 charge, which means that over here, manganese is +6 and oxygen is 2 minus. Okay? And manganese and oxygen have made a complex ion. They have joined together to make a complex ion. So this -1 is the charge of the overall ion. Okay? But this ion is a mixture of manganese and oxygen. The manganese element has +6 charge. So it's going from +6 to +2. It's becoming less positive. When the oxygen charge becomes less positive, that means we are gaining electrons. The gain of electron is reduction. Now that we have figured it out, let's take a look at how we're going to solve the question. To solve the question, I'm going to do the first thing. First step is the same. I will write down both the equations in such a way that I'm going to make sure that the arrows are on top of each other. That's the first thing I want to do. I want to write it down in such a way that the arrows are on top of each other. So over here on the left-hand side, I have MnO4 minus plus 8H plus 5. And on the right-hand side, I have Mn2 plus 4H2O. And if I go ahead and I add them up, and let's see what answer I get. Now, automatically, both of you should be able to spot a problem. What's the problem you guys should be able to spot? The fact that our electrons are not balanced. You will automatically see that our electrons are not balanced. That's what you guys are going to go ahead and see. Now, when we are going to go ahead and talk about it, you need to balance out the number of electrons. Like I mentioned before, to figure out the balancing of the electrons, you guys will have to, at that point, look at the question and decide what you have to do. Right? That's not something that's going to be the same every time. It will be up to you guys to look at that point and figure out, okay, now what am I going to do? So in our case, if I want to balance out the number of electrons, I will have to multiply both the equations. Because I cannot multiply 2 by any number to turn it into 5, right? 5 does not come in the table of 2. So I will have to multiply both of them by a number to make sure that the number of electrons become same. So what I can do is that I can take my top equation and I can multiply this by 5. If I multiply the top equation by 5, so 5 2s are 10. My electrons will turn into 10 electrons. And I can take my lower equation and I can multiply it with 2 5s are 10. So again, in both cases, I'm going to end up with the number of electrons balanced. At the top, we will have 10 electrons and at the bottom, we will have 10 electrons. Then last step is actually quite easy. The last step is simply the fact that we add up and get our results. So what are we going to do? On the left-hand side, we start adding everything up. So we have MnO4. And then we have 8 hydrogen ions. And then we have 2 iodide ions. I'm writing it incorrectly. You guys did not correct me and tell me that. I have not bothered doing any multiplication. if we bothered with the multiplication, we would see something like this. So I have 5 ml of 2 ml of, right? Because we have to multiply both the equations by the, we have to multiply both the equations, right? So the top equation is being multiplied by 5 and the lower equation is being multiplied by 2. So I will have 2 mn of 4. Plus 8 twos are 16. So 16H plus. Plus I have 2 iodine. I have to multiply 2 iodide by 5. That gives me 10 iodide ions. Right? Now, do I need to worry about the number of electrons? I do not. Because the number of electrons on the left side are equal to the number of electrons on the right hand side. So they will be cancelled out with each other. Right? So I don't have to worry about them whatsoever. Now I can write my arrow. Then 5I2 plus 2Mn2 plus 2 for the 8, 8H2O. And this is our final answer. This is the final overall equation for this particular reaction, right? Our electrons have been cancelled out from each other. Our electrons have been cancelled out with each other. So this will be your final equation. So this is how you guys can go ahead and construct a overall balanced equation. This question we also understand. We understand how we're getting this particular answer. And this portion is all clear. Anybody has any confusion in this portion?
No.
Aruj, is everything all clear in this part? Okay, now let's take a look at another one. Hold on, let me just share that. Give me 1 second and let me just open up another question. Here is another question. Let's take a look at this one. This is again, now the question that we're going to be taking a look at, this question is slightly more complicated than the one we done before. Okay, the reaction between aqueous between aqueous, potassium, magnate, and again the charge on magnate is, let's say, 6, and hydrogen peroxide involves 2 changes represented by the half equations. Construct a balanced ionic equation for the reaction. And what are the 2 half equations that have been provided to you guys in the exam? So the 2 half equations that they have gone ahead and given to you are that you have equation number 1 is your MnO4 minus plus 8H plus 5 electron minus, and this is giving us Mn2 plus 4H2O. So similar to the equation we did in the previous question, okay? Almost exactly the same as the equation we did in previous question. So how is this going to be different? This is going to be different like this. The second reaction we have is hydrogen peroxide. This is the equation that is provided to you with hydrogen peroxide. Now, step number 1. You will, again, step number 1 is the same. Write down your equation and make sure that the arrows are on top of each other. So I'm going to go ahead and write down my equation. And then we have to make sure that the arrows are on top of each other. That's very important. That's always going to help guys in solving the question. On the left hand side of the arrow, I only have one H2O. On the right hand side of the arrow, I have 2H plus O2 plus 2E. Okay. Now, I need to go ahead and balance it out. To balance it out, what do I have to do? To balance out, again, my problem is the same. What's my problem? My problem is that the number of electrons are 5 and 2. So to balance it out, I can take the top equation and I can multiply it by 2. And I can take the lower equation and I can multiply it by 5. Right? Problem solved, the number of electrons are going to be balanced. So my equation at the top is going to become 2MnO4 plus 16H plus 10 electrons, and this is going to give me 2Mn2 plus, and I'm going to end up with 8 electrons, 8 water. Similarly, we do that for the lower equation. So we are going to multiply all of it by 5. We'll get 5H2O2, right? Then we will get 10H plus, right? 5O2, and then again our number of electrons are going to become 5 2s are 10. Now, if we do the total, so we are going to go ahead and see that the number of electrons on both sides are balanced. So 10 electron will cancel with 10 electron. Then if I write it down, so I'm going to writing it down as 2MnO4 minus plus. Now, the reason I even went over this question with you guys is that I wanted to remember how I said that it's not just the electrons that can cancel out. Anything or any ion that will be on opposite sides of the equation, any ion, any element that's on opposite sides, you will subtract them. Over here, I have, if you take a look, I have 16H plus and then I have 10H plus. And both of them are on the opposite side of the equation. When they are on the opposite side of the equation, what do? We always subtract. So 16 minus 10 becomes 6H plus. So I won't write down 16H plus. I will write down 6H plus. That is why I went over this question with you guys, because I wanted to show that it's not just the electrons that get cancelled out. We don't just subtract electrons. We can subtract other ions, other elements as well, right? If they are on the opposite side of the equation, we will subtract. If we're on the same side of the equation, we will add. As a result, we will end up, so 6H plus, and then of course, I forgot to write down 5H2O. This will give us 2Mn2 plus 8H2O plus 5O2. And this is going to be our answer. Do we understand? Is this all making sense? How we're going to figure out the overall equation?
Yes.
Aruj, everything is clear? All right. Okay, guys, so we're going to go ahead and we're going to stop it over here for today. And then, inshallah, in the next class, we are going to take a look at how to figure out the oxidation stages in complex ions, so like MnO4. So how will you figure out what is the charge on manganese ion? So inshallah, we'll take a look at that. And we will also take a look at how to figure out your oxidizing agents and reducing. All right. Okay, thank you so much. I'll see you in the next class. Have a good day.